Okay, right. So I will copy the sum here. You can so the latitude position A is latitude 01 degrees 24.5 minutes south, and longitude is 105 degrees 32.0 minutes east, and position B is latitude longitude. Wait until I write this one, then I will show you the full screen. 00 degrees 05 decimal 0 minutes north, 099 degrees 28 decimal 6 minutes west. So okay, right. So can you all see the see what I'm writing?
Yes, sir.
All right. So let's start. As I told you, if you can remember, you write it like this. I gave you a standard format. If you want, you can use this format. So the latitude here, the longitude here, and position A 01 degrees 24.5 minutes south, and the longitude is 105 degrees 32.0 minutes east. Then position B is latitude 00 degrees 05.0 minutes north, and longitude is 099 degrees 28.6 minutes west. So 05 00 099. Okay. So now, if you can remember, I told you to draw two things. One is a cross and the other one is a circle, and put G here. So which represents the uh, prime meridian. And this is representing equator, right? So let's see. Position A is on south. A is here, right? Then position B is on north. So you can see you are moving towards north. So put north. Now let's mark the longitude here. Once you mark the longitude here, it is, so this is 90 degrees, this is 180 degrees. So easterly 105 degrees. You are somewhere here. Okay, then sorry, I'm sorry. This is not east now. This is west, right? So easterly 105 degrees. You are here, and westerly 099 degrees, more than 90 degrees. You are here. So what is the shortest distance from A to B? You can see it is the anti-clockwise direction. This is the shortest. Can you see that? Are we clear, guys?
Yes, sir.
Right. So this is the shortest distance. So in that case, we have to add these two and subtract it by 360 degrees. So let's add these two and subtract. 1 minute, I take my calculator. So until such time, you can also do the sum and put the answer. Do the sum and put the answer, please. You can put the answer in the WhatsApp group or here, it doesn't matter. So let's add these two, 24.5 plus 5, which is going to be 29.5. All right, okay, and 0.1 degrees. Then longitude is going to be, you have to add, in this case you can see that you have to add, because the shortest distance from A to B is the anti-clockwise direction, so you have to add and subtract it by 360. So in this case it is going to be 28.6. So 1 minute, guys. Okay, right. So 32 plus 28.6, which is 60.06, 0.6, and 105 plus 0.99 plus 1. So the answer is 205 degrees, right? Okay. Okay, minus 359. You can easily do this with your scientific calculator, but unfortunately I cannot show it to you here because uh, online I will not be able to do it. So then 60 minus 0.6 is 59.4. So, and anti-clockwise direction. So what is the anti-clockwise direction? Is it easterly or westerly? It's easterly, right? So anti-clockwise direction is easterly. Did you all got the answer? Or is my answer is correct?
Yes, sir.
Yes, sir.
All right. So what you have to remember here, that clockwise is westerly, anti-clockwise is easterly. Especially when you are calculating your D long, you have to make sure that what is the direction that you are moving on to. If you are moving anti-clockwise direction, wherever you are, it is easterly, right? And if you are moving clockwise direction, it is westerly. So let's do the next sum. So any questions, guys, before we move on to the next sum? Are we good?
Yes, yes.
All right. So let's go with the second sum. So the second sum is position A is, now you can see how I am writing left and long, because I used to do this because it's easy and it looks nice. When you're writing it in a log or something, um, I mean, you can use that, you can straight away write lat and long, but I used to do this. Anyway, 10 degrees, 54.9 minutes north, longitude 178 degrees, 48.3 minutes west, then position B. You can see how I'm writing position. Let me write it back again. So in short form, I'm writing the position POS and simple N on top with a underscore, right? So position B, let and long, 0, 0 degrees, 32.8 minutes north, longitude 169 degrees, 22.5 minutes east. So let's do the sum. Some more guys are joining. Okay. So let's do the sum. You can see what I'm writing, right?
Yes, sir.
Okay. So position A, position B, latitude. If you write in this fashion in your uh, exam paper, anybody can easily identify what you have done. So I suggest you follow the standard that I have given to you. But you can, if you have your own standard, you can use that as well. So anyway, latitude A of position A is 10 degrees, 54.9. Latitude B is 0 degrees, 32.8 minutes north. Then longitude of A is 178 degrees, 48.3 minutes west. Longitude of B is 169 degrees, 22.5 minutes east. So we are going to calculate the D-lat and D-long in this case. And as I told you, you just draw the cross and the circle with G, right? These are 90 degrees, 180, right? This is east and this is west. Uh, this is east and this is east is in this side, west is in this side, right? So now in this case, position A is on 10 degrees north, coming down to 0 degrees north. So you are moving southward. So put the sign as south. So then the longitude, position A is on west side, 170 degrees, and position B is on east side, 169 degrees, somewhere here. So you are moving A to B, right? So what is the direction uh, of your D long? Is it easterly or westerly? Clockwise direction?
Still.
Westerly. Very good. So it is westerly. If you do it like this, you will never miss, I mean, you will not do any mistakes as long as you draw the diagrams. In any sum, you try to draw the diagrams, right? That is the best way to identify where you are going. So in this case, you can see it's a simple subtraction for the latitude. So that is you subtract 10 degrees 54.9 minus 32.8 is 22.1 and 0 9 degrees 9 degrees 22.1 1 minute south. And here in this case you can add these two together and subtract it from 360. So when you add these two, which is going to be 48.3 plus 22.5 is 70.8 minus 60 is 10.8, then 178 plus 169 plus 1, which is 348. So 60 minus 10.8, 49.2, right? 359 minus 348, which is 11 degrees. So guys, most of the time I'm doing silly arithmetic mistakes. I always do that. So if I'm doing any mistakes, you have to be very, I mean, you have to focus on what I'm doing. If I do any mistake, please always raise your hand and tell me that the answer is wrong. So in this case, is this answer is correct?
Sir, excuse me, these latitudes coming 10 degrees 21.12, but sir written 09. Maybe sir, I think sir is correct, but my one coming is 10 latitude.
1054.900 degrees 32. You mean DLAT, right?
Yes, sir. Sorry, delay.
Let's see. Let's do the calculation again. 54.9 and 48.3, right? Sorry, 54.9, 38 decimal. So latitude A is 10 degrees, 54.9.
Yes, sir.
Latitude B is 0 degrees, 32.8.
Yes, sir.
So you have to subtract you have to subtract these two, right?
Yes, sir. Minus.
So when you minus 54.9 minus 32.8 is 22.1. And oh right, okay. So I have done a mistake here. See, okay, it's all
Okay. Okay. Okay, sir. Thank you, sir. Yeah.
yeah, yeah, yeah. So that's why I said, see, I am always doing arithmetic mistakes. Please make sure that you always, that's very good. So I can see that you guys are focusing on this. Right, so let's go to the next sum. Let me write the sum. Position A, 1 degrees, 54.9 minutes south, longitude 174 degrees, 40.3 minutes west. Position B, latitude, longitude, which is position B is 1 degrees, 33.1 minutes north, 179 degrees, 22.5 minutes east. Okay, let's double check. 1 degrees, 54.9 minutes south, 174 degrees, 40.3 minutes west. 1 degrees, 33.1 minutes north, and 179 degrees, 22.5 minutes east. Yes. Okay, so let's do the sum. Position A, position B, okay, position A, latitude 1 degrees, 54.9 minutes south. Position B, latitude is 1 degrees, 33.1 minute north. Position A, longitude is 174 degrees, 40.3 minutes west. Position B, longitude is 179 degrees, 22.5 minutes east. So I will draw my circle here. So these are 90. So you can see position A. Somebody else is also joining. Okay. So position A is on south, right? Position B is on, the latitude is on north. Sorry, B. So A to B here is traveling towards, you're navigating towards north. Are we clear? Okay. So next one, position A, longitude is on west. So A is here at 174 degrees. Then position B is on east side at 179 degrees east. This is B. So you are traveling towards A to B and with the shortest distance. So in this case, You are moving clockwise direction. So what is the direction that you are moving now? If it is clockwise, what is the direction, guys? Can you hear me?
Westerly.
Westerly, sir, westerly.
All right, very good. So westerly. So now again we have to add and subtract. Okay. Uh, right. So how to add and subtract? 40 decimal 3 plus 22 decimal 5 minus 6 is 0.2.8, and you have to add 174 plus 179 plus 1, which is 354. $57.2. Right. So this is 0.6 degrees. Is my answer is correct? Is my D long is correct?
Yes, sir.
Okay. So this is going to be 0.3 degrees because you have to add these two. You are in north and south. So is my answer D lat and D long is correct?
Sir, may 5 degrees D long.
5 degrees. Okay, අපි බලමු අපව හදලා. So you have to add 40.3 plus 22.5, which is 62.8 minus 60 is 2.8. Then 174 plus 179 plus 1, which is 354, 2.8. 60 minus 2.8 is 57.2, right? 359 minus 54 is, yes, 5 degrees. This is 5 degrees, yes. I don't have a scientific calculator. If I have a scientific calculator, it's easy to do this, but I'm doing it manually. That's why. Anyway, I'm always doing this mistake, so don't worry. Right. Uh, and you guys don't do these mistakes, huh? I have done my exams, so you are doing the exams, so it's good that you always keep an eye on the arithmetic mistakes. Right. Okay. So shall we move on to the next part now? I think you are very familiar with the D lat and D long calculation now. Are we good?
Yes, sir. Thank you so much.
All right. So let's go move on to. Can you all see my screen now?
Yes, sir.
Okay. For a navigator, okay. Now let me go back to my previous screen. Okay. Now assume that this is the Earth and you are in ocean, Indian Ocean or something, right? You are here in port A and you are supposed to go to port B. So in basically, as a navigator, what you should know is two things. Number one, you should know, right, where to go. That means you should know your, let's say this is north, you should know the direction of B in order to proceed from A to B, right? So you should know how to find out the direction. That is your first requirement as a navigator, right? So you should know where to go, right? Next one, you should know what distance to go, right? How much distance you have to travel from A to B, distance, right? So the third thing is, once you come up into the ocean, you should know where you are. You must be able to find your location. Otherwise, you will be ended up somewhere here, or you will be ended up somewhere here. So what is required is that you should find your location as well, your position. We don't call it location, we call it your position. Are we clear? So the navigator's job is to find out these three things. Number one, you should know where you are, your position. Number two, you should know what direction you're supposed to sail, right? So we don't call it direction. What do you call it? You should know your course to steer. Number three is you should know the distance to go. You should know your course to steer and you should know your distance to go. Are we clear?
Yes, sir.
Right. So this is navigator's job basically. So if you can do these three things, you can reach from A to B, right? Uh, so now, how are you going to find your position is now, though in the current system, the මේකාලෙදී you have the GPS to find out your position, right? Then I think we were the last generation who were using other celestial means to find the position. අපි මගිතන්න අන්තිම ජෙනරේෂන් එක ඔය සෙක්ස්ටන් එකෙන් පොසිෂන් හොයපු ඉස්සරහට එන ජෙනරේෂන්ස් මං හිතන්නේ සෙක්ස්ටන් එකෙන් පොසිෂන් හොයාගෙන නැවක් ගෙනියයි කියලා because you have the GPS and I'm sure you will also not find the ship's position by using the sextant, right? But you have to learn it. So ඉස්සර navigators පොසිෂන් එක හොයාගත්තේ sextant එක භාවිතා කරලා, right? එතකොට coast to steer එක හොයාගත්තේ calculation එකක් කරලා සහ distance to go එකත් හොයාගත්තේ calculation එකක් කරලා. So අපි දැන් මෙතන ඉගෙන ගන්න ඔයගොල්ලෝ celestial navigation වලදී ඔයගොල්ලෝ ඉගෙන ගන්නේ position එක හොයාගන්නේ කොහොමද කියලා. In this case sailing method වලදී ඔයගොල්ලෝ හොයාගන්නවා coast to steer එකයි distance to go එකයි. ඕක තමයි වෙනස. So position you will learn it in celestial navigation. GPS එකේ position එක හොයන්න calculate කරන්න දෙයක් නැහැ. GPS will directly give you the position. But those days, I mean, before the GPS came in, you had this Lorenzi and stuff, but I have never used Lorenzi. Before that, any electrical means, the navigators used to calculate everything manually by using the sextant. ඒක තමයි ඔයගොල්ලෝ ඔය offshore navigation එකේදී ඉගෙන ගන්න යන්නේ. You will be learning that celestial navigation, right? So then as terrestrial navigation එහෙම නැත්නම් මේ course එක කීයද කියලා හොයාගන්න එකයි how to find the course and the distance is what we are going to do as sailing types. Okay, are we clear guys?
Yes, sir.
All right, so what happened in the ancient time, I mean before the GPS, morning time, the chief officer is taking something called a position line using the using a heavenly body. Then may heavenly bodies can what are heavenly bodies? Right? I'm sure you have heard about the if you are already doing the course, you must have heard something called celestial sphere. Celestial sphere කියන්නේ මොකද්ද? What is celestial sphere? Celestial sphere is if you take Earth the whole, this is Earth, right? All heavenly bodies. You can see sun, moon, star, you can see sun here, you can see moon here, right? Assuming that you are stationary, Earth is stationary, all the objects, once you go out in the night time, you can see the sky. So whatever the object in the sky is called heavenly bodies, right? Heavenly bodies. So you will see heavenly bodies once you go out, and you don't feel that you are moving. You feel that the other objects, the heavenly bodies, are moving. Actually, you are moving around the sun, but what you feel is that you are stationary. That all the other heavenly bodies are moving around us. So that's why, long time back in the history, uh, especially the Catholic Church was strongly believed that Earth is stationary and all sun, moon, and everything is moving around the Earth. I'm sure you know about Galileo Galilei. What happened to him? He basically said, no, the Earth is moving around the sun, and he was just about to be killed because of that. But anyway, now we know that we are moving around the sun, but relatively, what you see is that Earth is stationary, right? Sun, moon, and all the other heavenly bodies are moving around us, right? So this sphere we call as the celestial sphere. දැන් අපිට මේ එළියට ගියාම රෑට එළියට ගියාම අපිට පේනවනේ අහස අහස සම්පූර්ණ බෝලයක් වගේනේ. ඒ ස්පියර් එකට කියන්නේ celestial sphere කියලා. Okay. So what happened in navigation, this is very much required those days. So early morning, chief officer watch එක මොකක්ද? Chief officer watch එක 48 watch එක. Right? Then 4 to 8 watch එකේ chief officer මොකද කරන්නේ? So what chief officer will do is he will take a star site එකක් හරි මොකක් හරි site එකක් දාලා sextant එක use කරලා එයා දාගන්නවා position line එකක්. You will not understand what I am saying now. ඔගොල්ලෝ මම මේ කියන එක ඔයගලන්ට දැනට තේරෙන එකක් නැති වෙයි. මම මේ කියන්නේ ඉස්සර පොසිෂන් එක හොයාගත්ත ක්‍රමය. ඒක තමයි ඔයගොල්ලෝ ඉගෙන ගන්න යන්නේ sextant calculations වලින්. Longitude by chrono and the other methods you will be learning that. Right? So මේ position line කියන එකක් හොයාගන්නවා chief officer උදේ watch එකේ. ඊට පස්සේ 8 to 12 watch එකට කවුද එන්නේ? This is chief officer.
Third.
Third officer. No. Yes. So what the third officer will do is he will use the sun because you can see the sun nicely from 8 to 12, right? Chief officer will be using the twilight time. I may twilight time make use කරන්න එයා because you need to find out the altitude of the star. Altitude එක බලන්න න altitude එක කියන්නේ horizon එකේ. You know the horizon. You know what the horizon is. Horizon එකේ ඉඳලා star එකට තියෙන උස හොයාගන්න horizon එක පේන්න එපා ඉස්සෙල්ලා. එහෙම නේද? Isn't it? Guys,
Yes, sir.
so you should see the horizon first, right?
Okay.
What time you can see the horizon is just before the sunrise. Sunrise එක වෙන්න පොඩ්ඩකට ඉස්සෙල්ලා horizon එක පේන්න පටන් ගන්න වෙලාවේ stars උත් පේනවා horizon එකත් පේනවා. අන්න ඒක තමයි twilight time එක කියන්නේ. So twilight time එකේ තමයි chief officer මේ වැඩේ කරන්නේ. Right? So you should know how to find out the twilight time. You should know how to calculate that one. හෙට තියෙන twilight time එක ඔයගොල්ලෝ offshore navigation එකේදී ඉගෙන ගන්න ඕනේ හෙට twilight time එක හෙට sunrise time එක හොයන්නේ කොහොමද කියලා. And you will be learning that one. Right. So I'm using both Sinhala and English. Anybody who cannot understand Sinhala, please speak up if somebody cannot understand Sinhala uh, because there are some guys who will be having trouble understanding English totally. So that's why I'm using because you need to understand the subject first, then we'll come to the English later. But to understand the subject, sometimes I'm using Sinhala as well. Anybody who cannot understand English, Sinhala? All are good? Okay, are you assuming?
Yes, sir, all are good, sir. All are good.
Yeah, okay. So 8 to 12 එකේ third officer ඇවිල්ලා third officer මෙන්න මෙහෙම position line එකක් දාගන්නවා. ඒක පොඩ ඇද වෙලා එන්නේ. Right? මට අපි මෙහෙම එනවා කියලා. Right? Third officer position line එකක් දාගන්නවා. Using the sextant. Right? Then noon time who's coming to the bridge?
Second mate.
So second mate is coming at noon time because he is basically the navigating officer. Why he is becoming the navigating officer? You can understand from this. ඇයි second mate navigating officer කියලා කියන්නේ කියලා මේකෙන් තමයි තේරුම් ගන්න පුළුවන්. So noon time එකෙන් මෙයා ආවට පස්සේ මෙයා කරන්නේ merpass කියලා meridian passage කියලා තව එකක් තියෙනවා. ඒකෙත් position line එක දාගන්නවා. මේ meridian position merpass එකේ position line එක always like this. ඒක එන්නේ east westerly direction එකට. ඒක පස්සේ තේරෙයි දැම්ම තේරෙන්නේ නැහැ. ඒ calculation එක කරද්දි තේරෙයි ඇයි මෙහෙම වෙන්නේ කියලා. But you have to understand the principle first. Are we clear?
Yes, sir, clear.
Yeah. So then
Yes, sir.
you will learn in chart work something called transferring of position lines කියලා එකක්. Right? Running fix කියලා කියනවා. ඒක එක නම් වලින් කියනවා. Transferring of position lines. ඔගොල්ලෝ chart work වලදී ඉගෙන ගනිය. Maybe you have already done chart work, maybe you already done running fixes. So this is the reason why you have to learn running fixes. Right? So transferring of position එකේදී මේ 8 to 12 4 to 8 position line එක එක then 8 to 12 position line එක දෙක noon time position line එක තුන එක transfer කරනවා noon time එකට මේ මෙතන හරියටම noon නෙමේ merpass time එකට transfer කරන්නේ okay noon time එක නෙමෙයි merpass time එකට meridian passage කියන time එකට මේක noon වෙන්නේ නැහැ noon එක ළඟ තියෙන්නේ ඒක ඕගයන්ට දැම්ම තේරුම් ගන්න බෑ ඒක පස්සේ තේරෙයි but I'm just showing you how the position was calculated those days okay and what I am saying is not in the books guys ඒකින්ද පොඩ්ඩක් ප්‍රශ්න තියෙනවා නම් අහන්න මේක මේ පොත්වල නැති දෙයක් මම මේ කියන්නේ ඉස්සර මේක you will not find it in Subramanian's book as well or any other book මේ අනිත් පොත්වල ඇති සමහරකට I'm not sure but මේ what I'm telling you is something practical right so මේක transfer කරනවා ඒ පැය ගානට ගේනවා මෙතනට okay number 1 එක ගේනවා මෙතනට ඊට පස්සේ number 2 එකත් ගේනවා මෙතනට so you can see here you can see there is a triangle getting created can you see that
Yes, sir.
මෙන්න මෙහෙම triangle එකක් create වෙනවා so this is called what do you call it what do you call this triangle this is called cock hat okay
Okay.
so then the center I mean there is a way to find out the center but normally this if this triangle is very small that means you have done your site properly මේ triangle එක පොඩි වෙනවා නම් ගොඩක් පොඩියට එනවා නම් ඔයගොල්ලෝ මේ site calculation එකයි මේ site එක දැම්ම ක්‍රමෙයි හරියට කරලා තියෙනවා. හැබැයි triangle එක ලොකු වෙනවා නම් ඒ කියන්නේ එක්කෝ X section එකේ error එකක් තියෙනවා. section එකේ වැරද්දක් තියෙනවා. එහෙම නැත්නම් ඔයගොල්ලෝ calculation එකේ mistake එකක් කරලා තියෙනවා. එහෙම නැත්නම් මොකක් හරි මැද mistake එකක් කරලා තියෙනවා. so මේක ආවම මේකේ හරි මැද්ද තමයි noon position එක හැටියට ගන්න. noon කියන්නේ merpass position එක. ඊට පස්සේ මේක අපි transfer කරනවා noon එකට. right so basically මේක noon position දැන් noon position එක දාන්නේ කවුද second officer දාන හින්දා automatically එයා තමයි නැවේ navigating officer වෙන්නේ ඉතින් දැන් මේ noon position එක දාගත්තට පස්සේ දැන් නැව කොහෙද තියෙන්නේ කියලා දන්නවා are we clear
Okay, sir. Clear.
okay then
Yes, sir.
position then other හිතන්නකො 20 so assume that we have found out the 29th noon position Okay, then you put it in the chart. So this is noon position. Now you are having your chart, you are having your waypoints in your course, waypoints in a course එකේ. You know the next waypoint to go. This is waypoint number, let's say waypoint number 3. Now you are here. Okay, now you are here. So you are going into, now you can calculate by using the sailing types. අපි මේ ඉගෙන ගන්න යන sailing types වලින් ඕගොල්ලෝ දැන් calculate කරගන්න පුළුවන්. You can use the sailing types and you can calculate what is the next course to steer to achieve you to reach this waypoint. මේ course එක කීයද කියලා ඔයාලට හොයාගන්න පුළුවන් දැන් calculation එකකින්. Are we clear?
Okay, sir. Clear.
Right. So මේ course එක and the distance to steer. Both you can calculate. So what we do is what the early navigators did was they corrected their course. Now you can find out from north what is the course to steer. Right? This is the course. Now you can find out, you can correct the course. Now until next day noon time. Right? So you are going to fix your position next day noon time. So until next day noon time, you will be steering in this course. දැන් මේ course එකේ තමයි ඔයගොල්ලෝ steer කරන්නේ. සාමාන්‍ය අපි හිතමු you'll be learning this course, don't worry. So let's assume that this course is 070 degrees true කියලා. So you are steering by using the magnetic compass, you are steering 070. Right? I'm talking about not the present navigation, the olden day navigation system. So 070 steer කරද්දී, right? Now, since the GPS is not there, you don't know where you are. There may be current coming in. Okay? There may be current pushing you somewhere. Let's say you are pushed upwards. So next day noon time, you may be ended up somewhere here. Did you understood? So I will draw it much more clear in a clear way. This is waypoint 3. This is your 29th noon. Right? You are supposed to steer on 070. And because of the current being pushed you have ended up on 20. So you do the same things that you have done on 29th. Morning site, third mid site, second main noon position. Then you can find out where you are. So apparently you may be, let's say, somewhere here on 30th. So again, now you have to correct your course and distance to reach waypoint 3. Do you understand now?
Yes, sir. Copy.
So this is what is happening because the GPS was not there. But nowadays you have the GPS, you have electronic chart system, everything. So you are basically saving your fuel and time. Okay. So, but since that electronic means were not available those days, they were sailing like this, right? You will be doing a sum called day's work. That day's work is totally applied to this method. Unfortunately, we are not doing day's work anymore, but still you are getting that sum in your exam. Okay. Day's work කියන එක obsolete ඒවා අවුරුදු ගානක් පරණ systems වැඩකුත් නැහැ. ඒ වුණාට unfortunately ඔයගොල්ලන්ගේ exam paper එකේ මම දන්න තරමින් තාම එනවා question එක. Okay, right. Do you understand how the previous seafarers, not the modern seafarers, the old seafarers were finding the position and the course and the distance to steer? ඒක පැහැදිලිද ඒගොල්ලෝ මොනවද කරේ කියලා?
Oh, sir.
Yes, sir.
Clear.
Okay, right. So now, as I told you, your main, as a navigator, you should know your position, where you are. Okay, you should know your position. So now you have the GPS. If you don't have the GPS, you have to use the sextant to find your position in the middle of the sea. But if you are in a coastal passage, ඒ කියන්නේ land එකක් එහෙම ළඟ තියෙනවා නම්, then you can use the you can do coastal navigation and use the radar or use the compass bearing, and you can find your position, isn't it? So you can use your chart work knowledge. Okay. Uh, DG. You can use your chart work knowledge to find your position in a coastal passage. Are we clear?
yes sir, clear.
For example, දැන් මොකක්ද ඒ කිව්වේ? ඒ කිව්වේ දැන් හිතන්න මෙතන ඔන්න ලෑන්ඩ් එකක් තියෙනවා. chart එකේ දැන් මේක මේ ලෑන්ඩ් එක. Okay. මෙන්න මෙතන පොයින්ට් එකක් තියෙනවා. තව පොයින්ට් එකක් මෙතන තියෙනවා. දැන් මේකට bearing එක දාගත්තම කොම්පස් එකෙන් මේකට bearing line එකක් ගහගන්න පුළුවන් මෙහෙම. Okay. ඊට පස්සේ මේකට bearing එක දාගත්තම මේකට bearing line එකක් ගහන්න පුළුවන් මෙහෙම. So this is going to be your ship's position. Understood?
Yes sir.
Okay, so this is coastal navigation. Okay, so in order to do coastal navigation, if you have a land or something, you don't need the sextant or you don't need the GPS. That is why those days, I mean, ancient navigators, they were always doing coastal navigation because at the middle of the ocean, it is bit tough to find the the position. Okay. And I will tell you a story now. Then ancient navigators right? ට මේ පොසිෂන් හොයාගන්න එක හරි අමාරු වුණා. මොකද මේ ක්‍රමයක් තිබ්බේ නැහැ. දැන් ඔයගොල්ලෝ මේ පොසිෂන් එක හොයාගන්න in order to find the position in deep sea, that is, then you need a sextant, right? In deep sea, you need a sextant. Okay, but after you after you take the altitude, then you need something else in order to go to the tables. Have you guys already, okay, before I proceed from this point, just tell me, is there anybody who are not studying the class 3 at the moment? Is there anybody who are planning to do the class 3 or any cadets from phase 1 or something? මොකද මගේ ඊළඟ පාර්ට් එක මම එක්ස්ප්ලেইন කරන්න ඉස්සෙල්ලා මට පොඩ්ඩක් දැනගන්න ඕනේ මොන වගේ group එකක්ද ඉන්නේ කියලා. So that I can start from the basics. මට පොඩ්ඩක් කියන්න navigation class 3 කරන කට්ටියට අමතරව exam කරන්න බලාපොරොත්තු වෙන කට්ටිය හෝ phase 1 cadets ලා ඉන්නවද මෙතන? Alright. Okay. Okay. Right. So then I will go very basic. I will just explain in much more comprehensively. All right. So can you understand these concepts, what I told you now?
Yes sir.
Okay. I mean,
Yes, sir.
if you are planning to do the exams in Sri Lanka, we have, in Sri Lanka, you have principles of navigation subject, isn't it?
Yes.
Yes.
Then you have ocean and offshore navigation. Okay. Then you have chart work, or we call it coastal navigation, isn't it? But in other countries, all these three are coming under one subject. Okay. Sometimes two subjects, sometimes one subject. Right? So in principles of navigation, you are basically going to learn about the principles behind all the navigation methodology. In this one, you are going to learn about the solar systems, moon, sun, those stuff. So you will be learning about the principles of navigation. Okay, in this one, you will learn about all the calculation of ocean. Once you go into ocean, you can't do coastal navigation, and then you know about the sextant calculation, right? Sunrise, sunset, twilight calculation, compass bearings, right? So these things you will be learning in this module, right? Ocean navigation, where you cannot see a land. Then you have to find your position and the distance and the courses and everything. In chart work, you are going to learn about coastal navigation. So that is how it has been divided here in Sri Lanka. All right. Okay. So now let's go back to the uh, the ocean and offshore navigation position fixing. So in order to fix your position, right, when you are in deep sea, you need a assume that you don't have the GPS. GPS නෙමෙයි දැන් මේ ඉගෙන ගන්න celestial navigation part එකේ principle එක මම මේ කියන්න යන්නේ. Okay, in deep sea you need the sextant. Okay, are we clear? So then you can find out what is the height to the star. You will not understand what I'm saying at this moment, but don't worry, you will later learn what it is. Why I am telling you all this at this moment is that in order for you to understand what is happening next, you should know these basics. මේ මම මේ බේසික්ස් ටික දැම්ම කියන්නේ ඔයගලන්ට පස්සේ තේරුම් ගන්න ඔයගොල්ලෝ කරන්නේ මොනවද කියලා. නැත්තම් ගිරව් වගේ ඔයගොල්ලෝ කරගෙන යනවා. මොකද්ද වෙන්නේ කියන එක දන්නේ නැතුව. නිකන් ගණන් ටික හදාගෙන යන එක විතරයි වෙන්නේ. Okay. So මේ සෙක්ස්ටන්ට් එක යූස් කරලා පොසිෂන් එක හොයද්දී ඔයගොල්ලෝ ඉන්ටර්සෙප්ට් මෙතඩ් කියලා එකක් යූස් කරනවා, ලොන්ජිටියුඩ් බයි ක්‍රෝනෝ කියලා එකක් යූස් කරනවා. ඔය මොකක් හරි මෙතඩ් එකක් යූස් කරනවා. ඒ මොනවා ගියත් ඕගලන්ට යන්න වෙනවා ටේබල් දෙකකට. එකක් තමයි එක ටේබල් එකකට කියනවා almanac එක කියලා. The other table is called Norris table. Norris nautical table. Okay. පැහැදිලිද?
ඔව් සර් පැහැදිලි.
දැන් මේ almanac එක යූස් කරනද දැන් ඔයගලන්ට තේරෙන්නේ නැහැ මම මේ කතාවක් කියන්න යන්නේ. මොකද මම normally I always tell stories. The reason is actually you will remember the story. Okay. So almanac එකේ තියෙනවා we call them ephemeris. පොඩි data වගේක් තියෙනවා. පස්සේ ඔයගොල්ලෝ අපි බලමු මොන what is almanac is. ඒ data බලන්න නම් ඕගොල්ලෝ දැනගන්න ඕනේ GMT time එක. GMT time එක ඕන වෙනවා මේ data බලන්න almanac එකෙන්. Right? So GMT time ඉස්සක මේ දැන් අලුත් මේ මොනවාද the present day clocks and ඉස්සල්ලා they were using I mean the old navigators were using something called chronometer. Okay, let me show you what the chronometer means. Okay, can you all see this?
Yes, sir.
Okay, it's basically a clock, nothing else. Okay, chronometer කියන්නේ ඔරලෝසුවක් පමණයි. Right? මෙතන මේක බොක්ස් එක දාලා වහලා ඒක ඩස්ට් එක යන්නේ නැති වෙන්න හරි පරිස්සමින් තියාගෙන ඉන්නේ. But okay, but until 16th century, 16th to 17th century, right? මේ ක්‍රෝනෝමීටර් කියන එක තිබ්බේ නැහැ. ක්‍රෝනෝමීටර් එකක් හදලා තිබ්බේ නැහැ. ඒකින්ද මිනිස්සුන්ට ලොකු ප්‍රශ්නයක් තිබ්බා. මිනිස්සු සෙක්ස්ටන්ට් එක පාවිච්චි කරලා latitude එක හොයාගත්තා. They found the latitude by using the sextant. There is a way you will learn that. Okay. But they could not find the longitude. They couldn't find the longitude until 16th and 17th century. So many, there are several people died because they could not find the position, right? And it was a nice story. There is a film also called Longitude. If you have time, right? If you like to watch films, go and have a look. There is a film called Longitude. There are two parts in that film. The film is based on a true story because the one of the Navy fleet, right? UK. In UK, you have some islands called Isles of Sicily, right? It was a Navy fleet. Because they could not find the position, they went and hit this Isles of Sicily, and they got they sunk basically, and so many people died because of that, because they could not find the position. So this was a serious issue those days, finding the longitude. They could find the latitude, but they could not find the longitude. ඔගොල්ලෝ ගිහිල්ලා බලන්න මේකට අන්තිමට එංගලන්තේ පාර්ලිමේන්තුවෙන් පනතක් ගෙනාවා. Longitude Act කියලා. ඒකේ ඒ ඇක්ට් එකේ හැටියට ඊට පස්සේ මේගොල්ලෝ ගෙනාවා තෑග්ගක්. කවුරු හරි longitude එක හොයාගත්තොත් ලොකු ගාණක්, ලොකු මේ තෑග්ගක් දෙන්න ඒ හොයාගන්න මනුස්සයට. Right? So then finally one woodworker, right? මේ මනුස්සයා මේ ලී වඩු කරන මනුස්සෙක්, as I can remember, he found the chronometer. Right? එයා තමයි පළවෙනි chronometer. එයාගේ නම John Harrison. Right? You go and have a look this history. It's very nice. Okay? If you want to become a navigator, you should at least learn about the history, what it is. Right? So his name was John Harrison, and he found the chronometer. But unfortunately, the prize was not given to him because he was not a noble lord. එයාගේ උසස් කෙනෙක් නෙමෙයි හින්දා එයාට ප්‍රයිස් එක දුන්නේ නැහැ. අවුරුදු ගාණක් එයා මැරුණාට පස්සේ තමයි මම හිතන්නේ ප්‍රයිස් එක හම්බුනේ මේ මනුස්සයට. right? So අවුරුදු 70ක් විතර ගියාට ප්‍රයිස් එක nominate කරන්න, because it's UK and lords are there, commoners are there. So it's ලංකාවේ තේම ප්‍රශ්න VIP නෙමෙයි හින්දා ඒක මනුස්සයට දුන්නේ නැහැ ඒක. Right? So this is a nice story. You go and find out the history of this. You can read this one. The person who found the chronometer is called John Harrison. It was not about the clock. ඒ දවසක ඕන තරම් ඔරලෝසු තිබ්බා, clocks තිබ්බා. හැබැයි clock එක use කරන්න බැරි වුණා නැවකට ගෙනියලා. They could not use it in a ship. Why? The reason was clock is made out of metal. Right? The chronometer is made out of metal. But metal, when the metal is exposed into the weather, for example, freezing weather, or maybe high temperatures, the metal expands and shrink. Because of this problem, the clocks were not keeping the correct time. Okay, that was the issue that everybody was having, how to build a clock in order to withstand the motion of the ship and the temperature variations. ඔය ප්‍රශ්නේ තිබ්බේ. Right? So if you watch this film, it's nicely shown there, right, how he was doing it. And those days in UK, in Britain, um, if somebody questioned the captain regarding the ship's position, it was considered as mutiny. ඒ කියන්නේ mutiny කියන්නේ නැවේ කැප්ටන්ට විරුද්ධව කැරලි ගහනවා. So he was killed. So nobody could question the position of the ship. Right? It is nicely shown in that film. Anyway, මම මේ ස්ටෝරි එක කිව්වේ ඔයගලන්ට අඩු ගානේ මේක ලොකු ඉතිහාසයක් තියෙනවා. මේක එකපාරට බිහි වෙච්ච මේ සයන්ස් එකක් නෙමෙයි. So you are learning a very grand science, which is navigation. Okay, so uh, this is your main task now. So instead of finding the position, I mean, you will be learning how to find the position using the sextant in your offshore navigation. But now since we are talking about sailings, right? Right. So what we are going to find out is the direction to or the course to sail. We are going to find out the course and the distance. Okay. So when you're going from A to B, you should know what is the course and the distance to sail. So if you take any point in the earth, there are only several directions that you can go. Number one, you can go north and south. On the surface of the earth, you can go north and south. Or you can go east and west. Sorry, the opposite. East or west. Isn't it?
Yes, sir. Sir, excuse me, sir. What's that movie name called?
Longitude.
Latitude?
Longitude. It's I mean it's the movie name is also Longitude.
Ah, okay, sir. Thank you. Longitude. Okay.
Longitude, and if you go to the history of UK Parliament, you can find the Longitude Act. Longitude Act එකක් තියෙනවා. Longitude කියන නීතියක් සම්පාදනය වුණා ওই ප්‍රශ්නේ හින්දාම. Anyway, so 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 you when you sail, I mean you have several directions and courses you can steer. So you can sail north and south, or you can sail east and west, or you can sail northeast, whatever the direction of northeast, or you can sail southeast, whatever the direction of southeast. Okay, so you can sail southwest, or you can sail northwest, isn't it? So if I categorize this sailing type, the first sailing type is you can sail towards north or south. Second one towards east or west. Third one is bit complicated. You can go towards northeast, right? Southeast, southwest, or northwest. Isn't it?
Yes, sir.
So we are
Yes,
going to
sir.
take one by one and have a look how to find the course and distance in both on all these cases. How to find course and distance in all these cases. Okay, right. So in the first type, going north or south, what is your course is going to be. Now, when it comes to the course, when you write the course, there are two ways you can write the course. Okay. First is the 3-digit notation. Digit notation. Okay. The second type is quadrantal notation. Give you you can write your course in these two ways. For example, your course in 3-digit notation always measured from north towards clockwise direction. Are we clear?
Yeah.
So in 3-digit notation, you always measure the course from north, okay, from true north, okay, on clockwise. Let's assume that you are sailing towards this direction. So this angle is clockwise, and let's say this is 060. So we all 3 digits, because your course can be 60, 120, right? Even it could be 1 degree. So there will be 3 digits. So that is why this is called 3-digit notation. For example, you always write the course. Let's say this course is 009 degrees. I have written here 3 digits. Can you see that? Never ever write the course as 9 degrees. You always write the course if it is 3 digits, 009 degrees. I'm telling you the traditions, okay? So these are the normal traditions that you have to use in navigation, because navigation is an art, right? මේක ආර්ට් එකක්. මේක නිකන් ඕගොල්ලන්ගේ මේ විභාගේ පාස් වෙන්න කරන සබ්ජෙක්ට් එකකට එහා ගිය දෙයක්. ඕකේ. ඒකට රෙස්පෙක්ට් එක දීලා ඒ ට්‍රැඩිෂන් වලට ගරු කරලා ඉගෙන ගන්න කියලා තමයි මට සජෙස්ට් කරන්න පුළුවන්. Right. So then, for example, this course is 060 degrees. Right. This course is, what is the angle? Let's say 100 and this is 90, so let's say 125 degrees. And this course is clockwise direction. How much? Let's say this is 180, so this is 205 degrees. Okay, and this course is how much? This is 270, this is 90, this is 180, this is 270, this is 90, this is 180. 180 වලට 90ක් එකතු වුණාම කීයද? 270. So let's say this is 300, for example. So you can see 3 digits always. You always write 3 digits in this notation and measure it clockwise. Okay. So this should be 090. Okay, this is 180. So can you see 3 digits? Are we clear? Okay, right. Next one is the quadrantal notation. When you, the same course here, I can write like this. Now you have north, east, south, west. Northeast, southwest. I'm sure you are watching the news, right? ඔය තියෙන්නේ live at 8 මොනවාද පැත්ත ගියත් ඇත්ත කියන ඔය ගොඩක් තියෙනවානේ. So news, northeast, west, south, news. Okay, so it's about news. I mean, the word news is from they have formulated from here. Okay, so anyways, assume that this course I want to write in a quadrantal notation. Always your north and south is very powerful. So your quadrantal notation is always starting either from north or either from south. So if it is north, this course I can write as north, let's say this is 60 degrees, north, right, 60 east. Remember, I only wrote 2 digits. Why? This course can only go maximum up to 90. It will not go more than 90. So it's only be that is going to be only 2 digits. Next one, if I write this course, as I told you, in this case, you have to always start either from north or either from south, which is closest to you. So in this case, south is closest. So you measure this angle. Let's say this angle is 40. So in this case, this course is going to be south 40 degrees towards east. Are we clear? Okay. This course, again, let's say this is this angle is like 50 degrees. Okay. Then it is going, we call it south 50 degrees west. All right. So this course, the strongest closest is north. Let's assume that this course is 20 degrees. Okay. This angle is 20 degrees. So this is going to be north 20 degrees west. So this is quadrantal notation. Are we clear, guys? Okay. I hope everybody understood. Okay. So let's now convert some courses. Any questions? Anybody is having a question?
No, sir. No.
Okay. So let's convert some courses 3-digit notation into quadrantal notation. Your first question. Okay. Can you convert 045 degrees to, this is 3-digit notation, convert it to quadrantal? Can you put the answer? Whenever you see something like this, it's better you always draw. So you can see this is, because it is I mean, you have to measure it clockwise direction, the 3-digit notation, this is 45 degrees here, and it is going to be what? North. How much? Tell me, guys. Just type it here so that I can see how you convert it to quadrantal. කොනෑනේ උත්තර.
Northeast,
Yeah, north 45 degrees
east.
east. Okay. So can you convert, please convert this one. 145 degrees. True. Convert it to quadrantal. And type the answer here. No, wrong. Like, as I told you, you have to find the closest, strongest point from north or south. Then measure the angle from the
Sir,
shortest.
southeast. Southeast 145.
Yes. So what you have to do, you first draw it. This is north and 145 is somewhere here. This is 90. This is 180, 145 is somewhere here. So you can see the closest is south and the other side is east. Okay. And this angle is how much? If this is 145, this angle is how much? 140, 180 minus 145, which is how much? 35 degrees, isn't it?
35 degrees.
Yeah, so the quadrantal course is going to be south 35 degrees east. Are we clear?
Yes, sir.
Okay, next one. Convert 315 degrees true. And give me a minute, I'll come back. Uh, give me a minute, guys. I drink some water and come. All right, I'm back. Can you hear me?
Yes, I can hear.
Okay, so what is the answer? What is my
So 45 northwest.
okay. So 315 is somewhere here, isn't it? This is north. So 350 is somewhere here, so that you can see this is the closest angle from north. And 360 minus 315 is how much? 360න් 315ක් අඩු වෙන්න ඕනේ කීයද?
45.
45. Okay. So 45 from north towards 45 degrees west. Remember, always north or south is powerful, though you have to always show north or south first. Right? Never ever write it like west 45 north. එහෙම ලියන්න එපා කවදාවත්. මේක මෙහෙම ලිව්වොත් ඒක වැරදි. Always you have to write either north or either south or north. Right? First. Right. So can you convert this one to 3-digit? South 25 degrees west. Convert to 3 digits.
So excuse me, sir. Can we write together northwest 45?
Sorry, something like this.
It's yes, sir. NW 45. Yes.
No, no, no,
Yeah.
no.
No, no. Okay, okay.
There are no any traditions like that. You have to always like this. So how much here? South, west, 25. Then you have 180 up to here. This is 180. So 180 plus 25 is how much? How much, guys?
205.
205 degrees. We normally put that this is true. Don't worry about this one. You will later learn why we put true. True කියලා කියන එකේ තේරුමක් තියෙනවා. ඒක පස්සේ ඔක තේරුම් ගනි. මොකද අපි ගන්නේ හැමතිස්සෙම true north එකේ හින්දා. Right? True north එකේ හින්දා තමයි මේ මනින්නේ. එතකොට true north, why you are taking because why we say true north, because there is a magnetic north as well. Right? Magnetic north is always not in the true north. That you know, I think. Right? Magnetic north, there is a small error from magnetic north එක හැමතිස්සෙම north pole එකේ නෙමෙයිනේ තියෙන්නේ. magnetic ඕගොල්ලෝ ඉගෙන ගන්න ඇතිනේ ඉස්කෝලේ යන කාලේ එහෙම. magnetic north එක ඇත්ත north pole එකෙන් true north එකෙන් පොඩ්ඩක් එහාට වෙන්න තියෙන්නේ. And it's changing as well. Yearly change එකකුත් තියෙනවා ඒකේ. Right? Those things we will learn later. Right. So right. So shall we convert one more? Then we'll go to the next part. Okay, north. 0.5. Sorry, north 0.5 degrees west. Convert this into somebody's phone is on. Okay, so what is the answer here? Can you put the answer? Type කරලා දාන්න බලන්න answer එක. Okay, right, yeah. As much as possible, guys, when you give the answers, try to talk in English because I would like to see how you pronounce this because once you become officers, you have to basically convey your messages to others through the VHF, right? So I would like to see how you guys are pronouncing this. So this angle is 0.05, right? Because of that, once you measure this angle, it is going to be 359 decimal 5 degrees true, right? Okay, right. So now we'll go to the next point. Uh, Now I'm sure you have understood what is quadrantal notation and what is the three-digit notation means. Okay. Are we clear? Anybody who does not understand that part? Anybody who doesn't understand that part? Anybody who wants me to do it again? Are we all good? All right. Okay, guys. So we are all good. So we'll now move on to the next part. As I explained, I will draw it again. As I explained earlier, we have these ways of sorry, we have these possibilities of sailing, or the direction of sailing will depend on these three types. Okay, isn't it? Are we clear? I explained it earlier here. Can you remember? Okay. Okay, so now, as I told you, what is the biggest, I mean, the main requirement is finding the course and the distance, right? So in this case, what is your course is going to be if you are moving towards north or south? There are only two possibilities. Your course is going to be either what? 0, 0, 0 degrees north or 180 degrees, sorry, 0, 0, 0 degrees true or 180 degrees true, isn't it? Okay. Now we'll come to the distance later. Not for the time being, we'll leave it as it is. We'll come to the distance later. So the course is going to be either 0, 0, 0 degrees true or 180 degrees true. In the second type, going along a latitude, we can say this is going along a latitude, okay, moving easterly or westerly, right? So what could be the course here? The course here would be going towards east. How much? So you go what? Type kara daan baga.
090.
Yeah. So it's going to be 0, 90 degrees true, and this one is going to be
180.
no, going westerly.
270.
Ah, yes. All right.
Yes, sir.
Okay. Now in this case, the third case, we have to, because there will be various courses that you will be sailing towards northeast or southeast or southwest or northwest. There will be various courses you can sail, right? There will be various courses you can go. So in this case, we have to calculate the course now in this one. But in the first and the second situations, we don't need to calculate because it's obvious that this is the only possibilities of courses that you will be getting, right? But in the third type, there will be various courses. So you can use the quadrantal notation or the three-digit notation to find out the course in the third type. Okay, right. So now let's calculate the distance. So in order to calculate the distance in the first case, right, can you remember the nautical mile definition? What is the nautical mile definition? Anybody? පොඩක් කවුරුහරි mic එක on කරලා කියන්නකො definition එක nautical mile එකේ. We did it last time or the previous session. Anybody? nautical mile එකක් කියන්නේ කීයක්ද? මම international nautical mile එක නෙමෙයි මම අහන්නේ. I'm asking about the nautical mile, not the international nautical mile. If you can remember the difference between the international nautical mile and the nautical mile I was explaining last time. What is the nautical mile? මතක නැහැ. It is what?
Sir, difference of the arc which made by 1 minute of the angle of the
Exactly.
center.
1 minute of the angle along what? 1 minute angle එක මොකක් දිගේද?
Over meridian.
Meridian. Yes. හරියටම හරි. ඒ කියන්නේ මොකක්ද? That is correct. So you can see if this is the earth. Remember, I told you we have a curvature issue, but normally for the navigation we are taking the center of the earth as the subtending at the center of the earth angle. We consider it as 1 minute here, right? 1 minute. මෙතන 1 minute එකක මේ distance එක තමයි nautical mile එක. Right? This is 1 minute of meridian, arc of the meridian, along the meridian. So this distance, so if we have 1 minute, okay, we consider it as 1 nautical mile. Okay, we never show nautical miles in meters. We don't show that. We always show the distance as an angle. For example, if you are going from here to here, A to B, this angle will be your distance traveled. And that is in how many minutes, not in degrees. You have to convert the degrees into minutes. Are we clear? Okay, let's assume that you are traveling from A to B, 10 degrees north to 20 degrees north. How many degrees in between? How many degrees?
10 degrees.
10 degrees. And that is equal to how many minutes? 10 degrees equal to how many minutes? Minutes කීයද? 1 degree එකට minutes කීයක් තියෙනවද? guys at least 1 degree එකට 60යි එහෙනම් මෙතන තියෙනවා 600ක් මිනිත්ස්. ඒ කියන්නේ nautical mile 600ක් මෙයා travel කරලා තිනවා. මොකද මිනිත් එකක් අපි ගත්ත එක nautical mile එකක් හැටියට. right 1 minute of the arc අපි nautical mile එකක් හැටියට ගත්තේ හින්දා තමයි දැන් මෙයා travel කරලා තින්නේ nautical mile 600ක්. so are we clear? එහෙම නේද? right so in this case you can see I will wipe out this one. In this case you can see that the cos is 0, either 0, or 180, and the distance is cos is 0, or 180, and the distance is equals to what? If you are going from A to B, distance එක equal වෙන්නේ කාටද? Can somebody answer? distance එක equal වෙන්නේ මොකටද? A ඉඳලා B යනවා නම් latitude එකක් දිගේ sorry longitude එකක් දිගේ A ඉඳලා B ට යනවා නම් equals to what? So somebody's okay. So you can see if you're going from A to B along a longitude අපි මොකද්ද මේ distance එක calculate කරේ?
Dilat.
D-lat.
Dilong.
D-lat long නෙමෙයි. ඇයි අපි යන්නේ longitude එකක් දිගේ උඩට. එහෙනම් මේ මොකද්ද change වෙන්නේ? එයාගේ latitude එකට change වෙන්නේ. latitude එක change වෙද්දි D-lat එන්නේ. So distance straight away equals to D-lat in minutes. එහෙම නේද? D-lat
Yes, sir.
in minutes. එහෙමනේ? පැහැදිලි නේද? alright okay so එහෙනම් මේක අපිට ඇත්තට මේ පළවෙනි type එකේ අපිට calculation එකක් නෑ basically we don't have to calculate anything. The course is basically 1, 0, 0, 0, 180, and the distance is going to be d-lat. Nothing to calculate there. Okay. But the problem is when it comes to the second type and the third type. Second type එකයි third type එකයිදී තමයි ප්‍රශ්නේ එන්නේ. Okay. So now we'll go into how to calculate second type and the third type. Right. Guys, I may have to take additional 15 minutes more than 2200 hours. Are we okay? විනාඩි 15ක් විතර වැඩිපුර ඉන්න පුළුවන්ද? Okay, the reason is I wanted to complete this second type. Okay. That's why. Okay. All right. Okay. Now you can see the second type. I'm going to explain the second type. Okay. Okay. Now in second type we call it, now if you go east to west, India, let me make a ලස්සනට අඳිමුකෝ නැත්තම් කැතයිනේ. Then you will say I can't even draw a circle. Okay. Thanks to the technology, I can draw circles now. Okay. Right. You will see this is the equator. Okay. And you are going from one longitude to another longitude from A to B. from A to B. Are we clear? Then we dot එකක් කරගන්න. You're going from A to B. And now you can see you are going towards east or west. So your course is going to be 090 or 270. Okay, if you go this direction, this is 090. If you go this direction, it is going to be 270. Can you see that? If you're going from A to B, it is going to be 090. If you're going from A to B. All right? Okay. Is somebody having a question? Nigoshan? Nigoshan. Do you have a question?
No, sir. No. No.
Oh, okay. All right. You are most welcome to ask questions. Okay, please ask questions. I wish to meet you all guys physically one day in a physical class. So let's see if we can arrange a class. I mean, if you can arrange a class, it's fantastic, all of you. If not, I will arrange the class. One day I would like to see you all physically. Uh, right, so you can see in this case, you're going from A to B, right? You're going from A to B. And your course basically is going to be 090 because you are going from A to B and you are going towards eastward, that is A to B, right? And you are going from C to D as well. C to D. Okay. So C to D, A to D, A to B is also 090. C to D is also 090. Okay. Right. Now you can see this longitude is, let's say this longitude is 10 degrees east and this longitude is 20 degrees east. So what is the D long of AB? D long of AB. How much? Here. 10 degrees east ඉඳලා 20 degrees east වලට යනවා. එතකොට D long එක කීයද වෙන්නේ?
10.
Okay, 10යි
10
මොනවද?
sir, 10.
10යි මොනවද? 10 degrees what?
10 east.
10 east. Okay. And D long of CD. What? Same longitude. Kiyad.
It's same, sir.
Same,
Same.
same.
Same. And if you are near the North Pole, even if you keep one step, okay, in the North Pole, somewhere here, right? Even if you keep one step, you may be doing 10 degrees east longitude, D long. So can you see when you are moving from A to B or C to D, can you take D long as distance measuring unit? D long අපිට ගන්න පුළුවන්ද A ඉඳලා B යද්දි හෝ C ඉඳලා D යද්දි හෝ North Pole එක ගාව කකුලක් එහාට තියලා distance එක measure
Cannot, sir.
කරන්න D long ගන්න පුළුවන්ද?
Cannot.
බෑ.
Cannot, sir, cannot.
බෑ. එහෙනම් අපිට තව අලුත් දෙයක් ඕන වෙනවා දැන්.
Departure.
We will require new thing, new unit. That unit we call the actual distance that we travel in nautical miles. We call it departure. Okay, that distance, AB distance, is the actual distance that we travel in nautical miles. We call it departure. I mean, when you shorten it out, we call it DEP. Are we clear?
Yes, sir.
Okay. So this new unit is the east-west distance traveled, right? Departure, let's define it later on, but for the calculation, you have to remember that. Departure is the east-west distance in nautical miles. So that will give you, the departure will give you the actual distance. So that means departure of AB, that means AB departure is not equals to CD departure, because that is the actual distance traveled in nautical miles. Are we clear?
Sir, please repeat again.
Departure එක කියන්නේ actual distance එකනේ nautical miles වලින්. එතකොට A ඉඳලා B ගිය nautical mile ප්‍රමාණයයි C ඉඳලා D ගිය nautical mile ප්‍රමාණයයි දෙකක්නේ. නේද?
Yes, sir, clear.
එතකොට departure කියන්නේ ඇත්තටම ගමන් කරපු nautical mile ප්‍රමාණය east west direction එකට. ඕකේ. පටලව ගන්න එපා. east west direction එකට ගිය nautical mile ප්‍රමාණය. ඒක මේ third type එකේදී use කරන්න බෑ. ඒක වෙන විදිහකට use කරන්නේ. මේ second type එකේදී second system එකේදී යන්නේ ඔයා latitude එකක් දිගේ යන්නේ. ඕකේ. latitude එකක් දිගේ යද්දී ඔයාගේ course එක 0900 හෝ 2700 තමයි වෙන්න පුළුවන්. හැබැයි actual distance එක travel කරපු එක වෙනස්. පේනවනේ? ඒ වෙනස් actual distance nautical mile වලට කියනවා departure කියලා. ඒකෙන්ද තමයි AB departure එකයි CD departure එකයි සමාන නැත්තේ. හැබැයි D long සමානයි මේ දෙන්නගේ. Are we clear?
Yes, sir, clear.
All right. So in that case, now let's calculate a formula. Let's derive a formula to find out what is the departure. දැන් මෙතන departure අපිට මෙහෙම නිකන් තිබ්බට හොයන්න බෑනේ. We need to derive a formula. මම දන්නේ නැහැ ඔයගන්ට formula එක derive කරන්න තියනවද කියලා ඔයගන්ගේ මේ අපේ ශ්‍රී ලංකන් මේ system එකේ, but anyway I will explain. Now you can see here, can you see my 3D view එක පේනවනේ? So you can see here, මෙන්න මේ කැලල තමයි departure එක. එහෙනම් මේ කැලල මොකද්ද? මේ equator
DeLong.
D long. Yes. For example, මේක departure නම් I will show you. If this is departure, this distance is D long. එහෙම නේද? Okay. So you can see here, මේක departure නම් මේක D long. එහෙමනේ? හරිනේ? මෙන්න මෙතන center එකේ ඉඳලා from the center අපි දැන් මේ perfect sphere එකක් හැටියට ගන්න earth එක. Earth is a perfect sphere. Okay? Not oblate spheroid, perfect sphere. So may distance එක මොකද්ද from the center of the earth into the surface? What is that distance? What do you call it?
Radius.
Earth radius. Yes. This is earth radius. Also this line is also earth radius. Isn't it? What about this line? This is also earth radius.
Same.
එහෙම නේද? මේක earth radius නම් you can see this. What is this angle? This angle is what?
Latitude.
මේ angle එක latitude වෙනවා. Why is that? Because our definition is latitude is the angle contained between the parallel of latitude and the equator. Sorry, the angle at the center of the earth O, arc of the meridian, measured in between the parallel of latitude and the equator. So this is latitude. Are we clear? පැහැදිලි නේද? Okay, එහෙමනම් now you see, okay, මේ angle එක latitude නම්, if this angle is latitude, one minute, okay, if this angle is latitude, this radius and this line is parallel to each other. මෙන්න මේ line එකයි සමාන්තර නැද්ද? මේ line එකයි සමාන්තර නැද්ද?
සමාන්තරයි.
සමාන්තරයි. සමාන්තර වුණාම you know from mathematics මේ angle එකයි සමාන නැද්ද?
සමානයි.
එහෙනම්
ඒකාන්තර
මේ
කෝණ.
එහෙනම් මේ මොකද්ද මේ තියෙන්නේ? මේ angle එක. මේක latitude නම් මේ angle එක මොකද්ද?
ලැටිටියුඩ් ඇන්ගල්.
That is also a latitude. එහෙමයි නේද?
yes sir.
මේක latitude නම් මේකත් latitude. ඇයි මේ දෙන්න සමාන්තරයි නම් from mathematics you know that these are the, what do you call it, what I can't remember what do you call it?
ඒකාන්තර කෝණ.
ඒකාන්තක කෝණ. Yes, okay. ඒකාන්තක කෝණ. Right. So I'm going to use that to do a small simple calculation, and we are going to consider this piece of circle, this chord, this piece of circle and this piece of circle. මේ red part එකයි yellow part එකයි දබා අපි දැන් consider කරන්න යන්නේ. Okay? පැහැදිලිනේ? Okay. Now let's go back to my Can you see what I'm writing? Can you see what I'm writing?
Yes, sir.
Okay. Right. So I'm going to prove something. I will draw the circle again. Now you can see, as I explained earlier, when you look at the, sorry. This is latitude of this position. Let's say this position is A, for example. This is equator. Can you see what I'm writing? Okay.
Yes.
So this is also latitude, and this is 90 degrees. Okay. This is the radius of the earth, because this is the radius. This is also radius of the earth. මේකත් radius එකක් වෙනවා. පැහැදිලි නේද? So if I take this triangle out, මෙන්න මේ triangle එක එළියට ගත්තොත්, it will be like this. This is radius. This is latitude. This is A. මම මෙතනට දැම්මා මොකක් හරි, let's say I will put D, for example. This is D, right? Then AD divided by R is what? AD from mathematics, AD divided by R,
cos lat.
cos latitude. isn't it? Are we clear? Okay. So one minute, guys. Okay, so AD divided by R is cos cat, right? And if I draw the other circle here, පොඩ්ඩක් මෙතන දෙන්නම්, wait. Okay, this is equator. This is, let's say, 20 degrees north. Okay, and this is the Earth center. This is D. This is A I was talking about. This is B. Okay, A to B you are moving. And this is, now we proved previously AD is what? AD you can see in the previous case. AD equals to, when you take R cos latitude. Are we clear? Are we good, guys? AD equals to R cos latitude. Okay, so in this case, R cos latitude. Okay, so if I take this triangle, not triangle, this piece of the circle and this piece of the circle, it will be like this. පොඩ්ඩක් මෙතන උඩින් අදින්න මට ඒක ඇඳ ගන්න නැත්තම් පොඩ්ඩක් බැරි වෙනවා. D A B and this one is, I will put CD here. So CE. CE. So this is center, this is C and E. Are we clear? Okay. So this is radius, but we prove that this is r cos theta. Sorry, r cos latitude. We proved that. Okay. So this is r cos latitude. This is r. And this AB is departure. This is departure. The actual distance that the and CE is what? CE is what?
D long.
D long. So you can see these are similar pieces of the circle. So similar pieces, when from mathematics you can see AD divided by C. I have put C here නේද මෙතන මේ පැටගෙනවා දැන් C දෙකක් තියෙන්න බෑනේ. එතකොට මේක මොකද්ද? We will put F කියලා දාමුකෝ. Okay. CF AD divided by CF is equals to AB divided by CE. From mathematics you know that. Similar codes. AD divided by CF is equals to AB divided by CE. Right? AD කිව්වේ R cos latitude. CF කිව්වේ R and AB is departure. CE is D long. So you can see R and R is basically uh, they will cancel each other. So departure is equals to so you can see departure divided by D long equals to cos latitude. Are we clear? Okay, the guys.
Yes, sir. Clear.
Okay, so that means departure equals to D long into cos latitude. Okay, since departure is in 1 minute of dlat, you have to keep the d long in minutes as well. Okay, so I will modify the answer like this. Modify the formula like this. D long in minutes into cos latitude. You cannot multiply a degree with a minute. If it is minutes, everything needs to be in minutes. Okay, but the latitude, since the latitude is a degree, it doesn't matter because it is inside cos. So that's okay. But departure and d long needs to be in the same units. So if departure is in minutes, d long needs to be in minutes as well. So this is your formula to find the distance in your second case. Since you are moving along the parallels of latitude, we call this sailing type as what?
Parallel sailing.
දැන් තේරුණාද ඇයි ඒකට parallel sailing කියන්නේ? Okay, this is why it is called parallel sailing. Okay, parallel කියන්නේ equator එකකට සමාන්තරව sail කරන හින්දා ඒකට කියනවා parallel sailing කියලා. ඒකේ course එක 0900 270. එතකොට distance දැන් හොයාගන්න distance සමානයි departure නේ. එතකොට departure කියන්නේ distance එකනේ. Departure is basically distance. So departure is basically equals to d long. මෙන්න මේ formula එක දාලා තමයි අපි මේක හොයාගන්න ඕනේ දැන්. Are we clear, guys?
Yes, sir.
Right. Now we'll go back to third one. Then third එකේ course and distance හොයන්න මෙච්චර සරල නෑ. It is complicated. There are three methods to find the course and distance in third type. That is 1, 2, 3. First method is called plain sailing. Okay. Second method is called Mercator sailing. Third method is called Great Circle sailing. So third method එකේ course and distance හොයන්න අපිට මේ sailing type තුනෙන් තමයි හොයාගන්න වෙන්නේ. ඒකෙන් අපි මොකද්ද use කරන්නේ කියන එක මේ ඒව කරද්දි බලා ගන්න පුළුවන්. මේක සමහර ඒවා වැඩක් නැහැ, සමහර ඒවා වැදගත්. හරිද? So you will see when we are doing the third type. So basically this is the sailing types. Right? So the core sailing types is this. There is nothing else that you have to learn for sailing to find the course and distance. To become a navigator, if you want to find the course and distance, these are the methods. That's it. But we are not using the plain sailing anymore. The most important sailing type is Mercator sailing, not even Great Circle sailing. Are we clear?
Yes, sir.
Right? But anyway, we have to learn all these three. We will learn that. But the most important sailing type is the Mercator sailing. You will learn that later why it is the most important one. Right? So let's go back to the parallel sailing. I will take only 5 minutes, guys. Let's do a sum. Assume that you are, right? A vessel is in 10 degrees north, right? Sailing from, departing from 20 degrees east and arriving 25 degrees east. Find the course and distance traveled. Okay. So then make හදන්නේ කොහොමද? You can see that it is plain sailing, sorry, parallel sailing, because you are not changing your latitude. You are in 10 degrees north. Okay. You are in 10 degrees north. You are going from A to B, right? Now in this case, you don't need to find D lat, but you need to find D long, right? When you are finding the D long, how you find the D long? Longitude A, longitude B. Longitude A is 20 degrees east. Longitude B is 25 degrees east. So you have to draw the circle. You are in 20 degrees east, A, and you are moving to 25 degrees east, B, and you are moving towards which direction? Easterly or westerly? Anticlockwise? You guys are already sleeping now.
Easterly, sir.
Okay. You guys are sleeping?
No, sir. No.
No, sir, no.
We're calculating.
Okay, some of you have left. Anyway, doesn't matter. So easterly, right? So the D long is how much? 5 degrees east. But as I told you, you cannot use degrees because you have to. Now, what is the course? What is the course in this case?
10. 10 degrees.
Course එක 10 degrees කියන්නේ නැහැ නේ පුතා. Course එක කොහොමද 10 degrees වෙන්නේ? Latitude එකනේ 10 degrees. Course එක මොකද්ද? What is the course, guys?
So 090.
090. Easterly යන්නේ. That is your course. Now what you have to find is the distance. So in order to find the distance, you have to put the formula because this departure divided, sorry, you don't have to put divided. So the formula is what? Departure is equals to d long into cos latitude, isn't it? So d long is how much? 5 degrees, but make sure that you convert into minutes. 5 degrees convert into minutes multiplied by 60 is going to be how much?
300.
300 minutes. So 300 minutes into cos latitude is how much? 10 degrees north. And the departure is equals to how much? Maganda දැන් තමා you need the calculator to do that.
294. 295 decimal 4.
295 decimal 4. Okay, let's see. I don't have a. All right, okay. How much? Cos 10 degrees into 300, which is 295 decimal 44 nautical miles. Remember, you have to mention nautical miles, okay? Because departure is a distance in nautical miles. So finally, your course and distance, you don't put right course and distance is equals to, how do you write this? When you are writing it, you write it in this way: 090 degrees true into 295 decimal 44 nautical miles. You write it like this, your answer. Even in the chart, you write it like this. Chart එකෙත් මේ විදියට ලියන්න. මේවා අර මං කිව්වේ navigational standards තියෙනවායි කියලා. So this is one of the standard. You write your course and distance like this with a cross. Are we good?
Yes, sir.
All right. Okay, guys. Some of you have left. I can see that. I will send you a couple of questions on parallel sailing. From next session onwards, we will complete all the sailing types except great circle sailing, because before great circle sailing, I wanted to do some celestial navigation, because there are easy methods to use in great circle sailing if you know celestial navigation. So I'll stop for the day, and thank you for joining, and I will send you a couple of questions. Do you have any questions to ask?
No, sir. Thank you.
Thank you.
All
Thank
right.
you, sir.
In that case,